Y'all, welcome back to some Algebra 3. This one's for Deli, because she wasn't here. All right, so on Monday, we talked about composite figures. Now, composite figures is when you have two equations, an f of x and a g of x, and one is made up of the other. We composite them. So when it says f circle g, it's a fancy way of taking the g of x function and putting it in for the x value of the f of x function. So let's kind of practice that to make more sense. So here we got two equations. We got f of x equals 2x minus 5, and g of x equals x squared minus 3x plus 8. We're going to start with f of g of x. That means we're going to take the g equation and substitute it for the x of the f1. So that's just going in right there. So that will look like 2 parentheses. We put the g of x function, 2x minus 3x plus 8. And then we continue the rest of that f of x function, minus 5. So then we'll distribute this to simplify it. We end up getting 2x squared minus 6x plus 16 minus 5. So the final answer is the simplified version. So let's simplify that. Add like terms, we do that right there, those two. We end up getting it to be 2x squared minus 6x plus 11. So that is f of g of x. So let's try the other one. The other one's saying, hey, what's g of f of x? That means we're going to take this equation and we're going to plug it in for both the x's on the g of x equation, both x's. So when we do that, we end up getting parentheses 2x minus 5 squared minus 3 parentheses 2x minus 5 plus 8. So as we simplify that, we have to square this. This is not saying distribute the two. No, no, no. This is 2x minus 5 times 2x minus 5. So we have to fill that out. When we do that, we end up getting 4x squared minus 20x plus 25. And then we're going to take this negative 3 and distribute into the next one. So we minus 6x plus 15 plus 8. So let's simplify that. So g of f of x simplified, add like terms. So we got 1 squared, so we're left with 4x squared. We got negative 20x minus 6x, so it gives us a negative 26x, and then 25 plus 15 is 40, plus 8 be 48, plus 48. So that's g of f of x. So you can tell how they're different. So it does matter which one comes first, which one's inside the other one. So this written in a composite figure will be look like this: g circle f of x. It's a circle, open circle, not closed circle. And this one be f g of x. That's the difference. Now, this next part of this is saying, hey, find f of g of 7 and g of f of 7. Since we already have these solved as far as what the function looks like, we're just going to substitute those values 7 in for x. So we have f g of 7 right here. So they just substitute 7 in for x. So we'll do f of g of 7 is equal to 2 times 7 squared minus 6 times 7 plus 11. We simplify that, we get 49 right here times 2 minus 42 plus 11. 2 times 49, so 49 times 2 gives us 96. So we got 98. 98 minus 42 plus 11. So 98 minus 42 plus 11 gives us 67. All right. Next one, we're doing g of f of x, of 7. So let's switch over. So in this equation, we're going to replace that with the 7. So g of f of 7 is equal to 4 times 7 squared minus 26 times 7 plus 48. Plus 48. So we simplify that 49. So it's 4 times 49 minus 26 times 7 equals 182 plus 48. So we got to multiply the 49 times the 4. So we get 196 minus 182 plus 48. So 196 minus 182 plus 48. Get a final answer of 62. 62. All right, so these are two answers for these. So most of the homework will be just this, but sometimes we get fractions. So let's practice some fractional ones here. So we'll start with f of g of x. So f of g of x. We're going to take the g equation and plug it in right there for the f equation. So we'll have 1 over, and only the x being replaced will be 5 over x minus 2. So just like all the other problems, we cannot have a complex. We got to get rid of this extra fraction. So to get rid of this x, you multiply this whole bottom side by a whole value x. But what you do to the bottom, you have to do to the top. So in doing so, we're left with x on top. Here, this is distributed to both of them. So it's distributed right here. The x's cancel out, leaving us just 5. Here, it does not cancel out, leaving us 2x. This is as far as this goes. We're done. We can't do anything past that. Let's look at the other equation. The other equation, g of f of x, means we're going to take this whole equation and replace just the x. So when we do that, it looks like this. It'll be 5 over 1 over x minus 2. So just like before, we cannot have this down here. So we multiply it by itself on the bottom. They will cancel out, but you have to do it to the top. So that crosses out, leaving us just a 1 denominator. Here, you distribute this 5 through. You're left with 5x minus 10. 5x minus 10 is your answer on that one. All right, one more for your legs. So this one's it seems hard, but it's really not that hard. So same thing, f of g of x. That means we're taking this g of x function and plugging it in for the x. So that means the only thing that's left there is the radical, and you're plugging that whole thing in. So it'd be x minus 3. That's as simplified you can do it. You can't do anything past that. So we let it be as it is. Now on a g of f of x equation, same thing. You're only replacing, let me change the colors right now. You're only replacing the x. So this is going in for x only. So when we do that, since we're only replacing the x, we're left with radical x minus 3. They look very similar, but the difference is the negative 3 is under the radical on this top one, and it's not right here. So that is composite figures with everything. So hopefully that helps you do this for all you guys that decided to skip class on Monday. I'm looking at you, Deli. Later, y'all.